That's fine. Miss Sparks?
Hey.
Hey.
I'm trying to pull up the test.
Oh, okay.
I think this is it. And then I had moved it down to there we go.
Yeah.
Do you want to go over the graph part?
Yeah, can we do 3 and 4?
Yes, ma'am.
Okay.
Okay. All right, on 3 and 4, the number 3 is exactly like the parent graphs that we did in the very first unit.
Okay.
So if I would have asked you way back then, Brooke, on this particular graph, it's the parent graph of the quadratic, which you would have known that. And you would have told me that it's adjusted right 5 and up 1. Does that ring a bell?
Oh, yeah, for sure.
Okay. So the reason why we brought this back in is to show you guys you already know something about these parabolas.
Okay.
And that would tell you that the vertex for this particular parabola is 5, 1 because you adjusted it right 5 and up 1.
Okay.
So you already have that, and you already know 2 additional things because you know the vertex.
Okay.
And that's that the axis of symmetry is x equals 5 because it's always the x coordinate of the vertex.
Mm-hmm.
And you also know that this is an even or a positive. So you know that because there's no leading coefficient, the leading coefficient is a positive 1. So you know it's a smiley face.
Right.
So you know that this, the y coordinate would tell you that there's a minimum of 1.
Okay.
So you already know a good bit just based on what you learned from the parent functions.
Okay.
But then what you would do is your little t-table is you would plug in that 5 and that 1. And I would just do something like go up 1 or, down 1, either way, and plug in a 4. 4 minus 1 is a -1. And -1 squared is 1. And 1 plus 1 is 2. So you know there's another point, and based on the symmetry principle of parabolas, you know that there's 1 over there. So there's your cute little parabola.
Okay.
Okay? Now, on this one, on number 4, this is called the intercept form. Yeah. And this tells me a couple things about this.
Okay.
I know that the intercept is +7 because we're doing all these factoring things. So it's going to be +7 and +3. That's where it crosses the x-axis. Because what we're doing right now is we're doing all that factoring, and then we solve to find the roots or the zeros or the intercepts. So we're trying to make that connection to show you guys how all this works together, So I know that that's where it crosses. And to find the axis of symmetry, because I know it's on the 7 and the 3, I can actually take those 2 points and add them together and divide it by 2 to find the axis of symmetry, because I know that they have to be, the axis of symmetry has to split those 2 points in 2.
Yeah.
Does that make sense?
Yeah.
Okay, so my axis of symmetry is going to be x equals 5.
Okay.
Okay? So AOS is x equals 5. Oh, they're twins. They were both x equals 5. But what I do know is that this one is a frowny face because the leading coefficient is a negative.
Right.
Okay? The other thing that I can do then is to find that other point it to figure out where that is, I can plug this 5 into the x's. So I would have negative 5 minus 7 times 5 minus 3. So that's a negative 2. So it's a negative, negative 2, and a positive 2. So that's negative 2 times 2, which is 4, times a negative 1, which is negative 4. So the axis, or did I do that right? Negative 2. No, it's a positive. It's positive 4. My bad, because a negative times a negative is a positive, and positive times that's a 4. I'm sorry.
It's okay.
I apologize. So the vertex is 5, 4. So I'm going to go over 5 and up 4. So my vertex is right there, and it goes through the intercepts.
Okay. Yeah, that makes sense.
Does that make sense?
It does.
Good. So what we were trying to do is show you, look, you've already learned number 3.
Yeah.
We're just reviewing and showing you how it fits in here. And number 4 was the connection between doing all this graphing and why in the world are we factoring? And that's to find the x-intercepts, or to put the equation into quote unquote intercept form.
Right.
Okay. So that was all that crazy business.
Yeah, which makes sense.
Okay. Let me erase some of this work so that I can walk through it again.
Okay. Thank you.
With you. Oh, no problem.
Thank you for doing this. My schedule's so bad today because of
mine is horrible today, and I'm very grouchy because of it.
Me too. And I have 3 tests tomorrow, so I'm not even going to dance tonight because I normally dance till 10 tonight. It's just
girl.
Sometimes I just have to take a day,
Yeah, I hear you. That's how Mo was sometimes with cheer.
Oh yeah.
Ugh. Cheer was so hard to do last year with her junior year.
Yeah, junior year's kind of bad.
Junior year is ugly.
You just got to get through it.
Yeah. What I may end up doing, because this is going to take a lot of time to erase, and I don't really want to do that, I think I'm going to see if I can find a blank screen. Oh, which has a lot on it too. Yay. Easier, but it's not.
And she also sent the answers out, so if you need to go, I can figure something out too if you need.
Well, I want to be able to walk through this one on the on here. The very first one, I would normally want to factor with you, but it's actually a perfect square. Because if you figure out what 2 factors that make 4, because what you're trying to do, oh, look at that. It's just acting 9 times crazy. Okay. What you're trying to do is what 2 factors of 4 add up to give you 4.
Right.
And that's going to be k plus 2, right?
Yes.
And k plus 2. Does that make sense?
Yeah.
Because 2 times 2 is 4, and then 2k plus 2k would be 4. So that one was pretty easy.
Yeah.
Really. But now on number 6, what you're trying to do is find 2 factors that add up or that multiply together to give you a negative 10.
Yeah.
That add together to give you a positive 3. Okay. So what I had done with Braden earlier was I did negative 10 and then positive 3. So what are the factors of 10? There's negative 10 and 1, or you could do vice versa. But if I combine those, that's going to give me a negative 9. That doesn't work. and then there's 5 and 2, which
Yeah.
if I do a positive 5 and a negative 2, that works. That does give me a positive 3.
Yeah.
So then what we would do is do n plus 5 and
Mhm.
n minus 2 equals 0. And now you have two little mini algebra problems. Oh, I
Mm.
forgot to do this on 5. I'm really sorry.
Oh,
What you were supposed to do is set that then equal to 0 and
yeah.
get k equals negative 2.
Yeah.
So I'm sorry about that.
That's
And
okay.
that's your final answer because you're supposed to solve by factoring.
Okay.
And so these, then you would set each one of those equal to 0. And so that's going to give you negative 5. And n minus 2 equals 0 would give you n equals 2. So your
Okay.
final answers are negative 5 and 2.
Okay.
Now, number 7, it looks a little weird.
Yeah.
You could bring the 0 over if you wanted to, but if you really think about it, one of the first things that you want to do, you want to make sure that it's in standard form.
Right.
And it's close to standard form in that it is, but it doesn't have a C value.
Yes.
The next thing that you want to check is there a greatest common factor, a GCF?
Okay.
And so you want to think about numbers and letters
Yeah.
every time you're thinking of a greatest common factor.
Mhm.
So is there something that n squared
Can you hear me?
barely?
Yeah, it's going out.
Okay. Can you hear me?
Yeah, I can hear you.
Okay.
Yeah.
Since I can't hear you real well, I'm just going to say that you can factor out an n,
Yeah.
and that would leave you with n minus 4 equals 0. But the key is although n is all by itself and real little, you
Mhm.
still have to count it as a factor. So you have to set it equal to 0 also.
Okay.
And then n minus 4 equals 0. So n equals 4. So n equals 0
And
or n equals 4 for
okay.
this one. Okay?
Okay.
All right. Now, on number 8,
Mhm.
can you think of two factors that would give you a negative 8 that when you combine them would give you a positive 7?
Um, like 7 and 1, like 7 times 1, and then
No, they multiply to give you an 8.
oh,
So the
um,
multiplication is the one on the end, and the addition is the one in the middle.
okay. Well, there's 1 and 4,
So
so that won't work.
so
And
what are the factors of 8?
there's 1 and 8,
Uh-huh. So
and
if I have a negative, so if you have 1, so 8, do a positive 8 and a negative 1.
yeah.
So what would that give me?
Well, a +8 and a -1 multiply to get -8, and they add to get 7.
There you go. So those are your factors.
Okay.
So my factors are x plus now she's been doing grouping with these. Do you want me to do it that way? Or do you like this?
Um, you're good like that.
Are you sure?
Yeah, for sure.
Okay. I know sometimes with the when the coefficient isn't a 1, it makes it a little easier to do grouping, and I can do that. And I have a thing I do called slide and divide.
Okay.
But we'll do whatever you want to do. You're the boss.
Okay.
Um
You did number 9 with me earlier.
Okay, thank you. And number 10, you want me to do that one then?
Yeah, if you don't mind.
Okay, so just like number 9, number 10 is not in standard form yet.
Right.
Standard form is when there's a 0 on the right
Mm-hmm.
and all terms are in descending order with the highest exponent going first. So
Okay.
the x squared is in good position, but
Yes.
I would need to add 8x to this side to get it from this side to that side.
Yeah.
And I would need to add 15 to get it from the right side to the left side. Does
Yes.
that make sense?
Yeah, it does.
Okay, so now it's in what we call standard form, with the terms all going in descending order. So
Okay.
now what we're looking for is two factors of 15 that when we add them give us 8.
Okay.
So 15 and 1 does not work. That would give us 16.
Yeah.
5 and 3 give us 8.
Right.
So we'll have x plus 5 and x plus 3 equals 0. You know what I didn't do, Brookie?
Hmm.
Also, on this one up here, I didn't set it equal to 0 and
Okay.
solve, and I'm really sorry.
Oh no, you're good.
So x equals -8 and x minus 1 equals 0. So x equals 1. So
Okay.
your final answers are -8 and 1.
Okay. Perfect.
And they have to be in a set.
Yeah.
Okay.
Mm-hmm.
All right. So now I've got my factors, which I then need to set each of them equal to 0 and solve.
-5 and negative.
So I got a -5 and a -3 as
Okay.
my final answers.
Okay.
And like I say, they go in a set.
Yeah. So like when we have a set, like what is that like getting for us? Is that like if you putting this on a graph?
Yeah, those are the
Okay.
x-intercepts.
Okay, that's what I thought, but
Yeah, just like when we were doing this up here on number 4,
uh-huh.
that's what you're getting.
Okay,
That's
yeah.
where that parabola will cross the x-axis.
Yeah. Okay. That's what
And like when it's a perfect square
hmm
and there's only one of those, it actually means that the vertex is on the x-axis
Okay.
because it dips, it touches, and goes up
Okay.
from there.
Yeah.
So kind of know exactly what it's going to look like on the graph. I mean, you might not get it perfect, like crossing the lines perfectly, but you'll have a really good idea by looking at these.
Yeah.
7 is definitely not in standard form.
Mm-hmm.
So
Oh, it cut out again.
and add 3 to the right side,
Yeah.
and then to get everything over to the, oh, please don't do this to me and Brooke. My pen likes to quit writing. And I don't know why it does that to me. Why? Let me see. I'll try and open it again and see if it works better.
Alrighty. Technology sometimes drives me crazy.
Oh, doesn't it?
Bro, I
You
never
really?
going on.
Oh, it makes me crazy.
I always have to have people help me and stuff.
I'm like, please, for the love of Jesus,
I know. Me
please
too.
open and don't be ugly. Just work.
I know.
What all do you have tests in tomorrow?
I have a big chemistry test tomorrow. And
Ugh!
oh yeah, and chemistry's not going good. Her
Oh,
test
baby
is
girl.
hard. And we
Yeah,
have
chemistry
to the
is hard. And then what else?
we have history and then what's the
Ooh,
oh, no, there's not. Oh, and a math test, obviously. But
yeah.
yeah.
Oh,
Yeah, so it's gonna be an interesting day tomorrow.
it is. Oh, that makes me feel so bad. Oh,
It's just a lot with like, well, and our teachers like kept telling us like at the beginning they were like, like we're watching the calendar like because they have like a shared one for all of the teachers like in the grade, I guess. And they're like, we're not gonna put like too many things on each day. I'm like, three different subjects is a lot for one.
yeah. Well, they tell us 4, but I'm with you. 3 is a lot, and that
Yeah,
makes me feel bad.
yeah, it's hard to balance.
Yeah, I try really, really, really hard not to do that, but
Yeah,
and I was gonna say I can check the calendar, but I didn't remember the history being on there.
yeah. Well, and I think it's just a quiz, but it's just a lot of information.
Yeah, it is a lot of information, but I didn't remember that it was on there. I try really hard if there's 2 on there already. I try to postpone
Well, and it really wouldn't have
or
bad.
or make it open note at
Uh,
least.
for sure. Well, and it wouldn't even be that bad if it was just a normal weekend. But like this weekend, I was gone until yesterday, like night, like on a church thing, like a.
Yeah,
So it's hard to like study for stuff over that weekend. I don't know.
yeah, yeah.
It'll all
True.
be.
Well, I'll definitely be praying for you guys for
Thank you.
sure.
Yeah, for sure.
P plus 3
Mhm.
and then P plus 1 because those are the factors that multiply to give you 3 that add to give you 4. So if I'm setting each one of those equal to 0 individually, that's going to give me P equals -3. And then P plus 1 equals 0. That would give me P equals -1. So my answers for this one are 3,
Negative one.
-3, and -1. So that's your set.
Right.
And these would be, like you had asked before, great question. These would be the x-intercepts.
Mhm.
They're also sometimes called the zero of a function. You'll get to hear about that later in the year also, or the roots. It's given all of those names. Roots, zeros, solutions, x-intercepts. They literally all mean the same exact thing when you're talking about graphing of parabolas or actually any type of polynomial, really,
Okay.
even logarithmic functions.
Oh wow.
All of that are the same things.
All right.
Actually, logarithmic functions, well, yeah, they do cross the x-axis sometimes. But you'll get to see all that luscious stuff. Yay.
Great. Can't
And
wait.
what you don't get this year, you get in pre-calc.
Oh,
So
wonderful.
fun stuff. All kinds of stuff to look forward to, Brookie.
Yeah, something like this.
Um, on this next one, obviously, it's not quite in standard form in that there's a -6
Mhm.
on the right side.
Yeah.
And so you would need to add 6 to both sides. I'm just going to show that because it looks weird when you do it and you're
Yeah.
like, did I do that right? And I don't want you to second guess yourself.
Yeah, I got you.
M squared minus M equals 0.
Yes.
So what you could do is factor that M out. So we're a lot like that one that we had earlier that was n minus 4, except this is going to be n minus 1,
Okay.
m minus 1. So you've got 0 and 1 as your solutions because
Yeah.
m would equal 0 and
Mm-hmm.
then m minus 1 equals 0.
Yeah.
So m would equal 1. Does that make sense?
Yeah, it does.
A lot of students get a little freaked. I even remember way back 2 years ago when Mackenzie was doing this,
Yeah.
and when she would see it, and it would just be something simple like factoring out either a letter or a small number.
Yeah.
You know, you get used to doing all these really big problems, and then you get to something like that, and you're like, what do I do with this little tiny thing? So I wanted to kind of make sure that there were a couple of those on there, just because that can happen on the ACT, SAT, and stuff like that also.
Yeah.
So, all right. So, number 13, once again, it's not quite in standard form in that the -3 is to the right where there should be a 0. So you need to add 3 to both sides. So you've got x squared plus 5x minus 14 equals 0. So what we're looking for is 2 factors of 14 that would make a -14, but at the same time would give us a sum of 5.
Okay. So 2 and 7.
Yes, ma'am. Good job. And the 7 would be the positive
Okay.
because this 5 is positive as far as the factors are concerned, because you would want that bigger one to be that. This is where grouping kind of comes in and takes a hold and does a little bit better of a
Yeah.
job of breaking that down. But in the end, once you set those equal to 0, your final solution is -7, +2 as far as where it's going to cross the x-axis. Because once I set this x plus 7 equal to 0,
Yeah.
it would become negative. Does that make sense?
Yes, ma'am.
Okay, good. All right. Any questions so far? Do you feel pretty good so far?
I do feel pretty good, I think.
Oh, okay. So, better than what you thought it was going to be, right?
Yeah, for sure.
Okay. The next two, um, the next two are the ones where I think she does grouping and I do something called slide and divide.
Okay.
But I'll do grouping, but I can show you slide and divide. But I think it's probably better to not learn some. Actually, I'm not going to even show it to you because I don't want you to have to learn something new before a test.
Okay.
You know what I'm saying?
I got you.
All right. So I believe what she does is multiplies the A and the C together, correct?
Uh-huh.
Okay. So 5 times 24, which is 120.
Uh-huh.
And then she takes the B value and puts it down here. Does she do it like that?
Yeah, kind of. I think she does it more like on the problem, like she makes like an M.
Oh, okay.
Like she makes like a V with the 5 and the 24.
Oh.
You know, does that make sense? Yeah, kind of like that. And then like she pulls down the 5 and stuff like later.
Okay.
Like
All right.
if that makes sense.
Yes.
Yeah.
So then we have 5x squared. And then we're looking for two things that multiply together to give you a positive 120 that when you combine them give you a negative 26.
Yeah.
So good times.
Yeah, that's a little much.
So obviously my bigger number is going to have the negative. So I would do a negative 120 and 1, which obviously that doesn't work at all.
Right.
And then we've got negative 60 and 2, which that would give us a negative 58. So we're getting kind of close.
Right.
Getting smaller anyway.
Mm-hmm.
And then I got tripped up on this problem with negative 30 and 4. And I thought, oh gosh, that's it, because that would give me a negative 26.
Right.
But technically, what I'm doing wrong actually is both of these should be negative. And that's when I fixed it, because this is a positive 120. So both of my factors have to be negative. Does that make sense?
Oh, yeah.
So that would actually give me a negative 34. So I'm not really there. So that's why I'm like, you have to be really careful with those signs.
Yeah.
So then I went down, and that negative 20 and negative 6 give me a negative 26. So
Mm-hmm.
yay, I found them. So that's negative 20x minus 6x plus 24. And then she would group it, right?
Yeah.
So she probably would take a 5 out of the front one, which
Mm-hmm.
gives 5x, and which would give me an x minus 4. And I didn't group that second one very good because I didn't take my sign with me. So I'm going to try and regroup that too. Sorry about that. Can you see it okay?
Yeah.
Okay, good. So then on this next one, I would take out a minus 6, and that would leave me x minus 4. So I have 5x minus 6 times x minus 4 equals 0. So if I set this equal to 0,
Mm-hmm.
that would give me 5x equals 6. So x equals 6/5. And if I set the x minus 4 equal to 0, it would give me 4. So my answer for number 14
Mm-hmm.
is 4 and 6/5 in a
Okay.
group.
What a weird solution.
Yeah, it is a weird one. I'm just glad I don't have to graph 6/5.
Okay.
I mean, it's easier to graph when they're decimals like that, unless it's 1/2. Like 1/2 is pretty easy to graph, but when you get into 1/3 and stuff like that, it's just, I don't know. It's just easier to look at it when it's a
Yeah,
decimal.
for sure.
All right, and then this next one, and I'll try to do it a little more like what she does it too,
Okay.
with the V. I'm trying to give myself space over here because I know that sometimes these can be humdingers.
Yeah.
Okay, so 7 times 10 would give me 70.
Mm-hmm.
Okay.
Mm-hmm.
And so I'm looking for two factors, once again, that are going to multiply to give me 70, but at the same time, when you add them together, they're going to give me a negative 19.
Right.
So if I'm going to look at that, I've got a positive 70. So that means both factors are going to be negative once again.
Mm-hmm.
So 70 and 1, that doesn't work. 35 and 2, that doesn't work. 14 and 5. Negative 14 and negative 5 work. So I've got minus 14x minus 5x plus 10.
Mm-hmm.
So I'm going to go ahead and group these. And I can take a 7x out of my first group,
Mm-hmm.
which gives me x minus 2. And I can take a negative 5 out of my second group, which gives me x minus 2. So my two factors are 7x minus 5 and x minus 2 equals 0. And once again, if I take each one of those and set them equal to 0, I'm going to get x equals 5/7. And then this one would be x equals 2.
Uh-huh. And on your, like, second set, like, is it, like right above where it says factor each completely, like where
Yes,
you that it says like -5 and then parentheses x minus 2. Why is that -2?
because I took out a minus 5.
Okay.
Okay, see this factor right here. I'm going to do green. This factor right here, if I take a
Yeah.
minus 5 out there, I'm going to get a positive x, because -5x divided by -5 leaves me a positive x. But a
Right.
-5 divided by 10, like if I took a positive 10 and divided it by a -5, I'd have a
Oh,
-2.
that's -2. Okay. I just wanted to make sure.
No, that's a great question.
Okay.
Great question.
All right. And then you did 16, 17, and 18 and 19 with me earlier. But I
I
was wondering
did.
if you could do 20.
Yeah, I can. I'm happy to do that. The key thing that I really are you, how are you feeling when you look at like number 16 and 17? Are you feeling really good about being able to identify the difference of squares?
Yeah.
Because that is a concept
Mhm.
that I believe, in my personal opinion, that is really like if you can recognize that pattern, that
Mhm.
will help you so much when we get to things like rationalizing the denominator with complex numbers and radicals, because
Okay.
you have to multiply the denominator by its conjugate, and the
Mhm.
conjugate, which I know this is a lot of information, but all of that is based on the difference of squares.
Okay.
So I just want to make sure that you feel really good about being able to break that down, knowing that that's going to be 2p plus 5, 2p minus 5 kind of thing.
Yeah. I think I.
Okay, cool. Okay, good. Now on number 20,
Mhm.
it's also this is a perfect square,
Right.
where you can look at that first digit and
Mhm.
see that it's a, or that first term, if you will, and
Mhm.
see that it's a perfect square.
Yeah.
And 3r is its square root,
Yes.
and 1 is a perfect square.
Okay.
And just to check to make sure that it works, I
Mhm.
always take the first term and multiply it by the second term, which gives me a 3r, and then
Mhm.
I multiply that by 2, which gives me 6r, and that is my middle.
Okay. Yeah.
Just to confirm, that it is that, like on this one up here,
Uh-huh.
4n, if I would have put plus 3, I would have ended with a positive 12n and a positive 12n,
Yeah.
which is 24n with a
Yeah.
positive, and I would have been, oh, that's not right because I'm looking for a negative. So I
Yes.
would have known to erase that and make sure that I put a minus.
Yeah. Gotcha.
Okay, how do you feel?
I think I feel pretty good. I'll go back through this and make sure I know what I'm doing again before tomorrow too.
Okay.
Um,
Um, well, just email me if you have any questions, okay?
hey, I will. Thank you so much for calling me after math lab.
Oh, you're fine, honey. I understand. And
Yeah.
I'll be praying for you and all your tests tomorrow, okay,
Thank
love?
you so much.
No problem.
Bye.
Bye.
Thank you.
You're welcome. Love you.